All financial support for this podcast comes from my patrons on patreon.com. If you'd like to join in with the patrons, please check out patreon.com/DarwinGrosse. That's DarwinGrosse. Now enjoy the podcast. Okay, today I have the great pleasure of meeting somebody who I've wanted to talk to for a while. We've been working on getting our schedules aligned, and it looks like it came together. His name's James McCartney, and most of you will know him as the father of SuperCollider. But he's had really quite a career in computer music, and I'm really happy to get a chance to talk to him. So with no further ado, let's talk to James. Hey, how's it going?
It's going well, yeah.
Thanks so much for taking the time to have this chat. Why don't we kick this off by just having you talk a little bit about where you're at right now?
Well, I retired from Apple 2 years ago, and I'm working on sort of my personal successor to SuperCollider. I'm not making it as a product, and I'm not making it as even something that I'm care too much about satisfying users other than myself, so
right.
Whether or not someone else will want to use it is a question, but yeah, that's what I've been doing. And also I've been playing a piano that I have, which is very unusual. It has a Jankó keyboard, which is a whole tone based.
Oh, cool.
Or it's isomorphic. So basically there's rows of whole tone notes that are offset by a semitone. Well, I have some MIDI similar kinds of things here. These are MIDI keyboards that are in the same layout, but it doesn't look the same as my piano layout exactly. But it allows me to play with the same fingering any key or pitch set, and everything can be mirrored around any point. Also, the width of an octave is a little bit narrower, so you can reach a little wider. So sure. It has a lot of advantages that I find very fun to play with.
Wow. So. I'm going to want to talk to you more about that. I can't even imagine. So you're saying you have an acoustic piano with one of these isomorphic?
Got a Jankó keyboard is what it was invented in like the 1880s by a guy named Paul Jankó. And for a while it was thought that it was going to replace the regular piano. Franz Liszt knew about it, and there were comments by people that would say, they thought this would replace the keyboard within, the regular 7.5 keyboard within 50 years. And there were 50 manufacturers for a while of this kind of piano up until about 1920 when they all sort of died out.
Wow, I had no idea. That's amazing. It's interesting because I've had a chance to talk to a lot of people, and every once in a while, like a whole class of instruments, someone will refer to that as something like they're into, and it's stuff I've never heard of before. I had no idea that there were acoustic instruments that were developed with these keyboards. That's wild.
It's a lot of fun to play because you can just do things that would have required unbelievable amounts of practice with the regular keyboard, but you can just sort of, blow them off really fast on this keyboard. So.
Yeah, well, I know that for a while I was using the Snyderphonics Manta, which has just kind of like an arbitrary.
I have one of those.
Yeah, and I had mapped it out to have a isomorphic layout.
Right.
And,
well, it's
and
very
again,
similar to the Manta. If you took the Manta and you made horizontal whole tones and the diagonal up to be a semitone, that's the Jankó layout.
Oh, well, that makes a lot of sense because then you learn cluster shapes and stuff, which are just like really easily translated to any key or any chord. Yeah,
that's right. Yeah.
Oh, very interesting. So, what is your involvement right now with SuperCollider?
Well, I'm not involved in SuperCollider right now. So when I went to Apple, the lawyers there sort of made clear to me that I was no longer allowed to contribute to open source software. I'm not sure if, since they had to start hiring machine learning people, and the machine learning people as a group would not sign on to any company that had that kind of restriction. So they've had to loosen up a bit, at least for the machine learning people. And I don't know to what extent they're willing to loosen up for other kinds of groups. But at least for me, when I signed on in 2002, I had to stop contributing to SuperCollider. And so I was out of it for years. And then in the meantime, I've sort of just decided, I've learned a lot in 20 years and I want to do something different now. So, I think I can do something, I won't say better, but just suits the things I want to do better.
What are those kind of things? What are the angles that you would like to now dive more deeply into?
Well, there's a number of things that I find they're just kind of workflow things. One thing is something like Faust, where you can compile unit generators instead of having them pre-compiled like you have in many systems. So rather than having a fixed set of unit generators that are pre-compiled, you just write the script and it compiles. Like in SuperCollider, there's something called synth-diffs, which are basically graphs of unit generators that get assembled on the fly, but they're assembled out of pre-compiled bits. I'm doing the same thing now, but I'm compiling the whole thing every time you write the script out. So
right,
that's one thing. Also, my sort of preferences in programming languages has shifted a bit more towards functional styles, and I'm really a fan of APL, which is a language about array processing, which often in APL you can write a lot of programs in a line or two that would have taken many more lines. So I really like this kind of brief way of expressing things. So I've incorporated some of those ideas into what I'm doing now.
That's really interesting. I remember the first time I saw APL code, it looked like somebody actually trying to create hieroglyphics for programming. And I know people that use kind of those kind of languages, for them, there's like a connection to the symbolic nature of it so that they can consume and see code in larger chunks because it has that kind of sense to it.
Yeah, I'm not going with the whole, it doesn't look like Chinese, like APL sort of looks like it's hieroglyphics, but, so I'm still using, normal ASCII key set. The guitar player Stanley Jordan, he had a big hit with Eleanor Rigby. Yeah. Well, he studied actually with Paul Lansky at one point, and he wrote papers on using APL to compose music. And there's papers you can find at the ACM, Association for Computing Machinery, but they're about using APL to compose music. So those are interesting. And I actually wrote him an email, and he wrote back very enthusiastically telling me about a MIDI sequencer he had written in APL. So.
Unreal. Yeah, that's wild.
Yeah, so I've been interested in those kinds of ideas. Doing, I don't know, I think of it as like composing functions to compose music. So
sure, right. That's cool. One of the things I like doing on my podcast is talking to people about their kind of like their background and how they got to be the creator or artist or combination often that they are. And I'm kind of curious, what is your background? Because it's interesting to me. You have a very computer science orientation towards your work in terms of language development. And, you were one of the first people that I felt like was really embraced a client-server connection in a musical environment. Also, you really do have a lot of kind of the computer music and the actual music background that's combined too. So I'm kind of curious where you're coming from. What's your background and how did you get to the point? Because I first ran into you as the developer of Pyrite, which was a language element, an object that implemented a language inside of Max. But there's obviously a world of work that you did before then. What is your background and how did it lead into that?
Well, I guess if you start at the very beginning, my mom switched on Bach. So that was my first introduction to electronic music. But, I thought it sounded interesting, but it didn't sort of turn me on yet. Sort of, as Morton Sabachna calls it, it was new old music. Then a friend of mine said, you should come see this movie called Sorcerer. You're going to like the soundtrack to it. And so I went and I did like the soundtrack, and which was by Tangerine Dream. And that was where I first heard that, you can use electronics to do all kinds of new things that have never been sort of heard before. And so I got like Carlos's Secrets of Synthesis. It was like, I think, a 3 LP set or something like that.
Right.
I sort of learned how to connect synth modules together, but I didn't have a synthesizer at this time. But I sort of learned what the basics were. And then as soon as I was able to take at the university, to take the electronic music course, I took it. They had a studio it was way off. It was away from the music building in an education annex, and there was a little crypt up at the very top of it, and they had an old Moog that didn't work anymore, and they had some Wavemaker synths and stuff like that. I made my first piece there, and then the next year they moved into a big fancy facility with a huge EMU and a Fairlight. So I got to learn how to patch a synth, and make all kinds of sounds with the EMU and do the digital stuff with the Fairlight. And so that's how I got, experience in making electronic music. But in the meantime, I was getting my computer science degree. And then after I got out, I worked for IBM for a while, and then I worked for the astronomy department at the university for a while. And actually at the astronomy department, my job was to maintain this little programming language that one of the professors had written that was used to analyze the data that came back from the Hubble Space Telescope. But it was a little programming language, so that's my first introduction to writing a compiler and that kind of thing. So learned both electronic music and compilers.
Right. Yeah, I was going to say in CS studies, you're always sort of like compelled to build a compiler, but normally you never do that or even think about doing that again, right? It's clear that was something that just really resonated with you.
I guess. I think once I saw Max for the first time and got involved in that, and I started writing little objects, and then I sort of figured that, well, Max is, for me, it was really good as a UI builder tool and an IO, for MIDI and stuff like that. But my ideas for making compositions required more kind of sequential code, and I wanted to do something that was that I could express in an algorithm more easily than I could with patching up Max objects, which I tried to do. I made some Max objects that were sort of based on a pull model instead of a push model, which was a little bit hard to do in Max. Right. And then I just decided, well, I'm just going to write a little scripting language. So that was Pyrite. First, before Pyrite, I wrote 2 other things. I wrote something that actually was called Xcode, but it was a little C-like scripting language, but it was not. I didn't find it flexible enough, so I kind of abandoned that one. And I also wrote another little score language called Script, like S and then the crypt, like cryptography, but because I thought it was a cryptic scripting language, but and I did a lot of things with that. I had a Nintendo Power Glove, and I used this script language to program music that I would do with the Power Glove.
Interesting. But
it was like algorithmic score based. It was it had things you could do in it, like similar to the things you could do in HMSL, which is like you have these trees of events, and they can sort of have random branches, and basically there's a score there, but it's got semi-random elements in it, or choosable elements depending on what you're doing with your interactive. Like with my glove, I could sort of choose a branch of the score to go down. Mm-hmm. But then I wrote Pyrite because I was still searching for something more general to be able to do list operations with, and that's what Pyrite could do.
Yeah, I think people coming to something like Max with a programming background, one of the things that actually is difficult is to say, there's a certain structure that comes when I'm trying to do, you mentioned it like algorithmic behaviors or algorithmic functions or whatever. You're used to a sort of way of dealing with it as a block of text or as a sequential set of steps that isn't, especially a set of steps with a lot of conditionals, that isn't very convenient in a graphics language.
Yeah. Well, one thing that was there's some things I found a bit hard in Max was like things like the data structures, like the call object, which is a data structure that's sitting in one place, and anything that wants to interact with it has to send a wire to it and somehow get the result back out from it, instead of passing it around and being able to use it everywhere.
Right.
So that was one thing. And then the other thing is about Pyrite is it had closures like scheme. So you could write a function and then pass the function around as a value. In a Max, you can't really if you write a little patcher, you can't send the patcher down a wire and have things send values into it and get them back out. So
right.
So those are the kind of things that I was trying to figure out how to do. And so Pyrite was my solution for that. And then that actually it really helped my Max patches a lot. It cleaned them up like hugely because the patch would just be the UI and all the logic could be just in the Pyrite object. And it made things on the Max level a lot easier to understand and not get sort of lost in a big, massive wires. So.
Right. Now, one of the things is most of what you're talking about here, though, it's around the generation of notes or generation of events. But as you went from Pyrite to SuperCollider, there's the whole world of sound generation and synth development as well. Where did that part of it come from? Because that's a big leap. It's a big leap going from generative event creation to synthesis and all of the synthesis options that you were bringing to the table.
Yeah. So back in 1986, I wrote, when I was in high school, I knew BASIC at that point, and I, heard electronic music. I hadn't gone to college yet. And so I wrote out on a sheet of paper, like a list of all the function calls I would need to make a modular synthesizer. And of course, this was in BASIC. And of course, there was no way that would be realizable because BASIC was just not the right language to do that kind of thing in. But I had the idea back in high school about what I needed to do to make a modular synthesizer in software.
Wow.
So in 86, this was like 86 was like 4 years out of college. I got a Mirage keyboard, which is a sampler.
Right.
The Ensoniq Mirage. And I wrote a piece of software that would generate, it was a modular synthesizer where you had modules, like I think there was maybe 8 modules, and they had jacks and patch cords. And then you could define of the 8 modules, you could choose what they were, like as an oscillator, as a filter, or something else. And then you patch them together and it would compute the sample, and then you could load that into the Mirage and play that sample. I tried to sell it, and I sold 2 copies. One was to Mark Polishuk, and one was to Ivan Cherpnin, who is Serge Cherpnin's brother, who was a teacher at Harvard, and I got to talk to him on the phone.
That's amazing.
So that was worth it. I thought, okay, so I only sold 2, but I got to talk to Ivan Cherpnin on the phone. So.
It's a win, right?
Yeah, right. And then I wrote another sort of follow-on to that, which is called Synthomatic, which was another software synthesizer. And for a while, the people who produced DEC, what was that company's name?
Oh, yeah.
They took an option to publish that software, but then they got bought by Macromedia, so that fell through. That software apparently got out to Oberlin. Someone had taken it to Oberlin, and then Curtis Rhodes sent me a letter. He apparently got it somehow and sent me a letter saying, "Oh, you should like do more work on this software, develop it." And so I had the Synthomatic software, and I had the Pyrite language. Then I was using Synthomatic to do a granular piece for a dance performance that was happening in Austin, where I lived. And it was taking a long time to generate the sound files because it was really slow. I had a Mac 2 CI, and there was no... the floating point in it was terribly slow. So on the day that the Power Mac came out, I went and bought... This is while I was trying to do this music for this dance performance. I went and bought the fastest one, and I took it home and recompiled my code, and it ran 32 times faster. And I was saying, okay, now it's running faster than real time. So I immediately had the idea, I'm going to take Pyrite and I'm going to take Synthomatic, I'm going to put them together and make a real-time synthesis scripting language. And that was version 1 of SuperCollider. So that's how SuperCollider happened.
That really helps stitch all of that together. That makes a lot of sense. Now, one of the things that When I first tried working with SuperCollider, one of the things that surprised me, or that was a new experience for me, was sort of the client server separation. Was that in there from kind of version 1, or is that something that was
version
done
3
later?
actually?
Oh, okay.
Yeah. So version 1 was kind of basically Pyrite with synthesis, and then version 2 was Smalltalk with a kind of a Ruby syntax, but I didn't know Ruby yet.
Oh, okay.
But they just sort of coincidentally have this similar syntax.
Yeah, that's true. Yeah.
So, but version 2 wasn't client server. The scripting language ran in the real-time thread, generating new synth voices and things like that in real time. Later, I just came up with the client server model later, and it was sort of an experiment, but I just pushed it out. I had tried one other experiment that I'd never published, which maybe that's the way I should have gone, which is I used SuperCollider to generate code for the synth defs. Basically, were generated C code, C++ code that got compiled.
Right.
And that was before Faust, but it was generated from SuperCollider code. But the problem is that the C++ compiler was so slow, it just killed interactivity. I mean, you'd write a script and then you'd say play, and then you had to wait for like 45 seconds or something for it to compile. And it was just not fast enough to get a turnaround so you could hear what you were wanting to. Of course, it's a lot better than the days when you had to wait a day. But,
yeah, I guess.
It wasn't like turning a knob, which is what I wanted it to be. That kind of latency. Just
sure.
You hit submit for your program, and then it's just like ready within a second. And so I didn't pursue that further. I gave a paper at ICMC about it, but I never did anything more with it.
Interesting.
And so then I did the server model, and that was just the server model was so I could get the language out of the real-time thread, so that there weren't pauses because of the language running.
Right. And it was also a really flexible way of kind of doing multi-threading without having to over complexify the code base, I imagine.
Yeah, well, the one thing that it enabled was having remote playing, because you could put the server on a machine over the network and things like that. So
yeah. Yeah, well, it's funny, too, because in a way, it's almost hard to remember back in those days. But you talk about like how, you got the fastest machine, and all of a sudden things are running 32 times faster. I think it's hard for us to remember the days when, the changes from model to model on machines were so huge, or the changes in compilers were so amazing. Or like I remember, there was a time where multi-threading in any kind of an audio application was just not even a reasonable consideration, just because thread swapping and data sharing was so incredibly slow.
On Mac OS, you didn't have.
Didn't even have it, right? Yeah.
Right.
Yeah.
You had you're running in a callback that was called by the OS, or and it was interrupting you. So.
Yeah, it's hard to even imagine now. So at some point you moved to Apple. Was there anything? What was sort of like the intervening steps before you got to Apple? I mean, you were working on the astronomy thing.
Yeah, I worked on the astronomy department, and then I started contracting. I left the astronomy department, I guess, in '95 maybe, or something like that.
All right.
And I started contracting for Level Control Systems, which was a company that got acquired by Meyer Sound ultimately. When I was there, we were working on digital audio mixers that were used for like the casino showrooms and cruise ships and big churches and things like that. Places where they needed large sound systems. It was basically a 128 by 128 mixing matrix.
Oh my goodness. Okay.
So you would buy these boxes, and they would implement like one tile of the matrix, basically, like an 8 by 128 slice of this matrix, and you could stack as many of them as you wanted.
Right.
It would do like 5-band EQ and delay on every input and output. So I wrote the software for authoring the cues for the for like running a show on one of these mixers. And it had a feature called Space Maps, which was a triangular mesh of speakers, and it could move sounds through these triangular meshes. And it's like Cirque du Soleil's Mystère show used it.
Sure.
And it was used in a number of shows, and it was used at the Hollywood Bowl in a lot of places. But so yeah, I worked for that company, and then I did a short contract with Arboretum Systems, which was a plug-in manufacturer, made something called Hyperprism. And then I started selling SuperCollider in about, well, I guess 1996. That's when I started selling SuperCollider, and in parallel with doing contracting for these companies. And then in 2000, I was only doing SuperCollider, and that lasted 2 years. And I got married, and I decided, well, I need to get a real job because I'm married now. And also, if I work too many years just selling my own software and I ever want to get a job, they're going to go, well, what did you do during these years?
Right. Yeah. Yeah, exactly.
So I decided I needed to get a job. So Austin is a great place if you want to live very cheaply, because I was living really cheaply. My mortgage was $700 a month, I think. I was able to live really cheap, but SuperCollider was making some money, but I wasn't getting rich or anything. So,
right.
And Apple gave me an offer that was really good compared to what I was making. So I went with them, and I got a chance to work on a really great audio system.
How much can you tell us about the work that you did at Apple?
So I worked in the Core Audio group, which is the group which is responsible for the operating system services for supporting audio apps. So I didn't have anything to do with iTunes or Logic, they were sitting on top of us. So, but I worked on things like the Audio Toolbox, which is a framework for doing encoding and decoding of various formats of audio and reading and writing files and things like that, and sample rate conversion. So I worked on those bits of software, and I wrote a number of audio units all there. And then I worked on other things that are either not interesting at all or not can be talked about.
Okay. All right. Well, we'll leave those on the table. Now, it's interesting, though, being involved in the Core. I would say that Core Audio is one of the secret power tools of computer music. Every once in a while, I find myself compelled to use a Windows machine. And when I do, I realize how difficult it is to have an audio system that's tacked onto the outside of the operating system, right? How painful that process is. The way that Apple kind of has audio as part of its core system software is really... It really is a power move, and it's made a lot of stuff that we do, if not easy, at least viable.
Well, I think the thing about Core Audio is, and I can't really say specifically what they're doing, but it started, I think, before I was there. It started with a really brilliant insight into the way that the lowest level should work to be able to get the timing right, and with minimum ways of being held up, and minimum overhead, or almost like no overhead. So there was a really great insight at the very beginning about how to build the whole thing. So I think that it gave a really good foundation for everything else to be built on. So I think that's why it's so successful, and more than some other systems. When you look at I think it's the Juice. People have a table of latencies of different audio systems, and Core Audio and iOS, which is also Core Audio, are all like down in the lower left corner.
Right.
And I think that's because of the way Core Audio was built from the very beginning.
Sure.
To make sure it's.
What was in kind of bigger than breadbox terms? How many people were involved in audio development at Apple? Was it a huge team, or?
When I started in Apple, the Core Audio group was, I think, maybe 10 to 12 people.
Okay.
And then there were a few people who were in the kernel group, who were responsible for that part of it. And then later there was the iPod group also, which was another separate group doing the iPod hardware, but they were not part of the OS at that point. iPod ran its own, operating system.
Sure.
Or had its own firmware, I
Right.
should say. As time went on, the Core Audio group acquired the people who had been in the iPod group, and they acquired the people that got hired from Beats. And so when I left Apple, it was over 200 people.
Oh my goodness.
Doing audio. Yeah.
Wow.
There are things that had grown it a lot. Like when the phone came on, there was a whole bunch of people who came on to do codecs and telephony and echo cancellation and all the stuff you need to do telephony correctly.
Mm-hmm.
That's a whole another industry of expertise that needed to be added on. So those people got added, and then there was Apple TV and the HomePod, and Apple started doing a bunch of audio things that needed acousticians and all kinds of stuff. So the audio group grew hugely.
Well, I think audio also in general became a lot more of a commercial thing. I mean, it's
right.
Not only audio devices, but even just audio as, important kind of cultural stamps, right? I mean, it amazes me now to have commercials where, they'll be trying to sell soda by showing someone doing an Ableton Live set, or they have I noticed last night they had the basketball player Damian Lillard trying to hawk a power drink while playing an MPC drum machine, right? It's almost like the world of audio and music production and all that stuff has really been mainlined as kind of a cool cultural stamp.
When I got out of college, I wanted to do something in audio. I came out to California because my aunt lived here, and I thought I'd go drop by Emu Systems, and I discovered they were working out of a 2-story house.
Yeah.
And this was the largest synthesizer company I knew of.
Right.
And so I thought, okay, I'm gonna have to find something else to do.
Yeah. What's my equivalent of that is that I had started doing a little bit of programming, audio programming, and I heard about these guys making an editor called SoundForge, and it was down the road from where I lived. So I was like, oh man, I got to go find out about these guys. I bet it's a cool company, and I wonder if I could get a gig. And it was literally a guy working in his garage, hoping to come up with something to sell. It's interesting to think about how small that world was at the time.
Yeah, and now it's huge. Now you can go to college and study audio signal processing and come out and have a really good expectation of getting a job. But when I did it, it was like, I sort of had to make digital signal processing degree because it didn't exist.
Didn't exist, right?
Yeah.
Yeah, that's really interesting. And boy, I've got a friend who I was just talking to the other day who is in the automobile audio thing.
Right.
Which, you think of car stereos and all that stuff. He's like, nah, most people don't understand that there are dozens of audio systems in a car. It's like all the different entertainment systems, all the different contact systems. He's like, now with electric cars, it's like, the vroom vroom sound on the outside of the car even is all stuff that's having to be generated by audio systems. He's like, you can't count on two hands the number of compressors that are in a typical car. I was like, wow, that's crazy. But he's like, there's, it's a real industry now, which is pretty interesting. So, so when you joined Apple, though, you had to kind of divorce yourself from the SuperCollider thing. Have you stayed connected with it in any way at all?
I was
other than watching from a distance.
I was following it. Yeah, I just decided I want to do something new now.
Sure.
So, and it's being maintained by a group of people who are very diligent about doing everything the right way as far as releases go and all this stuff, which, I've never been a really good process person with, software releases and that kind of thing.
Right.
So, when I was at Apple, there were people who took care of that stuff, and
that's what their job.
It was fine with me because I just wanted to do the problem solving and coding, and I didn't want to have to. The process stuff was not something I was that interested in. So there's a lot of people doing SuperCollider releases now, and they're making the trains run on time, which is something I can't really.
Yeah, well, it's probably important though too, because there are a lot of products now that are kind of where SuperCollider is an important, at least, component of the products. Again, I know I use the mono Norns, and for which SuperCollider is an important part of that entire environment. So, I think that you actually are. It's a really compelling thing to talk about, having people focusing on keeping their trains running. It's cool. Right. So now you're retired. You're playing around with oddball keyboards and stuff like that. Do you get a chance to play much music?
Well, I play my piano every day. I mean, I haven't played out anywhere.
Right. That's what I was asking. I mean, it's because I would think, especially on the West Coast, because now, with the move to Apple, you moved out to the West Coast. I would think that your name would be a kind of a draw, just sort of like among the underground computer music geeks. It's like, oh, let's go watch James McCartney play a gig.
Well, at some point, I might, start playing out. Right now, I'm getting my son through high school, and once he's off to college, maybe I'll have time to do that kind of thing. But
that sounds cool. So, boy, I just looked at the counter and I see that unfortunately our time is already up. I can't believe it. But before we go, for people who want to kind of like stay connected to you and whatever work you're doing and however you wanted to share it, what's the best way for them to stay? So like for me, I stay connected to you kind of by following you on Facebook. Is that the best way?
Well, that's kind of my only outlet right now. I've thought about I should start a blog or something, but I'm too busy in doing development of what I'm working on to really have time to go off and write something about what I'm doing.
Yeah.
Because one thing, I'm changing my mind every week or two about what my direction is. But so then I'd have to go back and delete my post or something. But no, I just I guess Facebook might be the only place I'm really online right now, and I'm not really posting a bunch of interesting computer music stuff there.
No, but you know what is, and actually, you've posited some good points on there about, people who are wanting to get into audio programming and some of these other things. I find your posts to be really, really pretty compelling and interesting too. So,
well, yeah, I mean, someone who's interested in doing audio programming or music audio programming, there's a ton of resources out there now. So I'd encourage people to go read the source code for C-Sound, VCV Rack, SuperCollider, because there's all this open source stuff out there, Chuck, and it's all out there. You can read it and you can figure out PD, pure data. So you can read how does an audio engine work? What are the issues that you have to deal with? Is so you can go through that code and look and find out how people are solving the problems. And the thing about these programs that I listed is that they're each solving them in a slightly different way. So you can learn multiple ways of doing it.
Well, and also the ones that you mentioned are not sort of like, they don't have the kind of opaque skin of Juice that a lot of other things do. And that's one of the things that recent post that you had talked about, like that Juice in a way kind of abstracts you from some of the things that you need to know as an audio programmer.
Right. I mean, so when I worked at Apple, we would interview a lot of people, and they'd been to college and they'd learned how to use Juice and some stuff. And, so they knew how to write the inner loop of a DSP program. But that's not the kind of work we did that much. I mean, we do write some audio units, but plugin manufacturers write the audio units. And we need people who, this was not me. I'm not we anymore. I don't work there anymore. But Apple needed people who knew what the issues were in writing an audio engine. Just stuff about threading and resource management and handling a bunch of the low-level signal processing stuff that you need to know to do signal processing to write an audio engine. And there are people who doing algorithm development, like in MATLAB and stuff like that there, but they usually also know C++ programming,
right?
And they know how to translate their MATLAB into efficient signal processing code. So there are people who mostly just do the inner loop stuff, but even then, ultimately they kind of need to know how the engines work. So people who only know Juice, we just sort of thought of it as like it's kind of sort of like a crutch, and people relied on it and didn't know what Juice was actually doing for them.
Right, right. Very interesting. Well, man, I want to thank you so much for having this discussion. Thanks for taking time out of your schedule.
Sure, yeah.
All right.
Great.
Many thanks to James for having the great discussion. It was really great to get caught up with him, find out what he's up to. I hope at some point we get to see some interesting results from this research he's doing, but in any case, it sounds like he's having a blast with it. I want to thank you for continuing to listen and for sharing this with friends, family, everybody that you know. If you have any questions, comments, or concerns, drop me a line, ddg@cycling74.com, darwin.gross@gmail.com, ddg@20objects.com. They'll all get to me. Thanks a lot for listening, and we will catch you next time around. Bye.